Hello students, today's session will discuss about the assembly language programming in the 8051 microcontroller. Well, while writing the programs, we have to make use of different software tools which are mentioned here on the screen. Say editor, then assembler, then linker or compiler. Now what is editor? Which will provide the facility to write our programs so that we can type our programs and can save as a .asm file. Now once our file is ready, we have to assemble it. So assembler is the software that will convert the assembly language program into the machine language. That will generate the .obj file. Then we have to use the link command. Using the linker, linker is used for linking the different modules like asm and t-link. We can assemble and link our programs, and finally we'll get the executable file. Now whenever we write the program in higher level language, that time we have to make use of the compiler. Compiler translates the higher level language program into the machine language. Say for example, turbo compiler, TC. Well, so that is about the different tools that are used for software development. In the computer, these are the three main languages. What is the machine language, then assembly language, and higher level language. Microcontroller or computer processor understands language of 0 and 1, machine language. So when we write the program in assembly language, that should be converted into machine language using the assembler. However, when we write the program in higher level language like C, then you have to convert that into the machine language using the compiler. Ultimately, finally, we have to convert that into the machine language, right? Well, so let us see how to write the assembly language program. In the 8051 microcontroller, you will find that here it is the format for the instruction consisting of 4 fields: label, mnemonic means the actual instruction, and then operands means the data that is to be used in the instruction, and the last is the comment part. This is just to understand what that instruction is going to do for our understanding. Then we have to use different assembler directives. What is directive? These are the directions to the assembler. In the 8051, mainly DB, what is the defined byte, that is used for defining the variable. If it is the word type, then DW, right? Then ORG, what is the origin, that is used at the beginning to indicate the start of the program. Then EQU, equate, that is used for defining the constant. Then let us say value of pi 3.14. That time we have to make use of EQU directive, and END is called as the end directive. That should be the last statement of your program to indicate that that is the end of the program. So these are the various assembler directives that are used while writing the assembly language programs in the 8051 microcontroller. To understand how to write and execute the programs, let us go through one simple program of block transfer. Here in this program, the block that is stored from memory location 10H onwards, total 5 bytes that are to be transferred from 10H to the 20H location onwards. So let us go through the program. We begin with the ORG statement, origin 000. The next first instruction, we are defining the counter. So initialize byte counter. Since we have to transfer 5 bytes, it is initialized to the 5. R3 register is used for that. Then Here 10H is to be loaded into the R0 register, that is the address for the source block, and then similarly 20H, that is nothing but the memory pointer for the destination block, right? Then after initialization part, what we are doing here, taking the first byte at 10H into the accumulator, and through accumulator then we are writing that to the destination memory location, which is pointed by R1, that is 20H. So first byte transfer that is occurred. Now what we want to go to the next memory locations for next byte transfer. So we have to increment both the pointers, source pointer and the destination pointer, and decrement the counter till the count becomes 0. We have to repeat the loop, and that is how one by one all the 5 bytes that will be transferred starting from 10H location onwards to the 20H location onwards. Once the count becomes 0, that will come out of the loop. So that is how we can transfer a block from some source memory location to the destination memory location. These are the comment parts, and the last is the end statement to indicate that it is the end of the program. I hope you understand how to write the assembly language programs. Then here for your understanding, some simple programs that are given. First one is for the addition of the two numbers. So you will find here add instruction is used. The data 1 and data 2, that is to be added, and result is available in the accumulator, that is stored at 4150 memory location, which is defined using the DPTR. And here, since external memory location we are accessing, MOVX instruction is used here. So accumulator contents are stored at that memory location. Then if our result is more than 8 bit, then we are using R0 register for the third digit. So if it is beyond that, that will be available, and that is again stored in the next memory location, that is nothing but 4151. So that is how we can perform the addition of the two numbers. Here a program for performing subtraction. Only difference is here you have to use SUBB, subtract with borrow instruction, right? Rest of the things are same like the addition program. Here we are performing the subtraction of the two numbers. Then in the multiplication, we have to make use of MUL instruction, and one must remember that in multiplication and division we have to make use of A and B register only. You cannot use R0, R1, R2 like that. Only A and B registers are to be used for multiply and divide. Now here multiplication, the data 1 is taken in the accumulator, that is taken in the B register, then data 2 is again taken in the accumulator, and then multiply instruction is used here. That will multiply the two numbers and result will be stored in the accumulator. That we are storing again in the memory location pointed by the DPTR, so 4150. And if our result of multiplication is more than 8 bit, then the higher byte that is available in the B register, that we are storing in the next memory location, that is 4151. So that is how multiplication that is performed using the 8051 assembly language. Now here another program is shown for performing the division. Only difference is that here you have to use div instruction, and here whatever is the result that is available in the accumulator, you are again storing it at 4150, but now the remainder, if any, that is available in the B register, and that can be stored in the next memory location. So 4151. So that is how you can perform the simple arithmetic operations like addition, subtraction, multiplication, and division. Now let us discuss one interfacing example. Here, interfacing of 8051 with the D2A converter. You know, D2A is nothing but the digital to analog converter, and we can generate the various types of waveforms. Here, the program that is written for generating the square wave. Now, while generating the square wave, what you have to do? Alternatively, you have to output the 00 and EFF onto the port, and in between you have to call the delay. So the nature of waveform you will get is nothing but the square wave, and you have to keep it in the infinite loop so that we'll get the square wave at the output. Now here the delay routine is shown using R1 and R2. The count is loaded and then that count is decremented. So two loops are used to generate the required delay, and that delay routine is called in the program using the L call delay. So that is how you can write the program for generating the square wave. Simple thing, you have to output alternatively 00 and FF, and in between you have to insert the delay. Now next is the small program for generating the sawtooth waveform. In the sawtooth waveform, again, what you have to do, initially output 00, then go on incrementing the count using INCA till it reaches FF, and then output 00 and repeat it again. From 00, it will again start incrementing till it reaches FF. Once it reaches FF, again output 00. So keep it in the infinite loop and you will get the sawtooth waveform at the output. Well, similarly, in this program, that will generate the triangular wave. This is similar to the sawtooth wave. Here, initially, the count 00 is outputted and then slowly incremented by 1 after each step till it reaches EFF. Then start decrementing the accumulator content. So the rising edge and then the falling edge that we will obtain of the triangular wave using this. So that is how we have to write the program for generating the triangular wave, and then using the L jump instruction, keep that in the infinite loop so that we'll get the continuous triangular wave at the output. So that is how you can write the simple programs using the 8051 assembly language, and you have to assemble those programs using MASM or TASM. 8051 cross assemblers are available. Link those programs, and then once the programs are bug free, you can execute the programs to obtain the desired results. Thank you.